Welcome everybody to the Terraform on Azure community call for November. Normally this is October if it was every other month, but as many of you were probably involved in, we had HashiConf last month at the beginning, so this ended up getting pushed to the beginning of this month. Always happy to be with all of you, and we have seen steady growth and participation, and we just want to welcome anybody who's here for the first time or is just checking it out. Appreciate having the community continue to just funnel in here, and hope you continue to reach out to some people and bring them in because we really do want to continue to keep you guys all updated. So quick sanity check as always. Just don't be a jerk is what we always say. I don't think we've had problems with it, and I don't think we will, but this is just the quick check before we get into everything else. For the agenda today, we are going to go through our usual thing about community, and then we have Mark here, and then we're going to wrap up with an AMA. Some of you who signed up for the agenda earlier knew that we originally had someone from HashiCorp scheduled. Unfortunately, they are sick, so we had a last-minute agenda change, which, if you've ever presented anything, you know is the favorite part of your job. So we will try to talk through the questions that any of you might have, but just to put that on your radar so you can start thinking about any questions that you might have. And without further ado, I will keep things going. So as always, let's talk through the quick overview. For those of you who haven't come to one of these before, we are the Azure deployments team, Mark, Gray, and myself. Our team manages Azure, basically anything that is a declarative tool, so ARM templates, Bicep, or Terraform, and our broader organization also includes CLI and PowerShell. The real goal for us is to make sure that all of you, regardless of what sort of DevOps experience you're looking for, are able to use it in whatever sort of way that you want to, and that is fully supported and ready to go for you, whether that's Terraform or Bicep or ARM templates. And this community effort that we started a little while ago, it's been almost a year now, or maybe over a year now, is really just about wanting to engage all of you and make you aware of how first class we want to treat Terraform and how much our team and Microsoft itself cares about the users here. But we also want to engage all of you in opportunities to speak, to share, to contribute, to learn, and to keep you in the loop, and of course to get your feedback. And as always, there's that link there for speakers. We will be trying to reach out to people to have maybe 2 speakers per community call moving forward. That would just really solidify that this is a community effort and it isn't just me and Mark running our show of saying our same updates, which of course we will when things are important that we want to highlight, but we want to make sure you stay up to date. In terms of the current community investments, this is just a quick little a comprehensive list of everything that we're doing. So feel free to share that Azure Terraform AKA link. If you're not already part of the community, make sure to join that. Join the Slack if you haven't. People like Mark Tinderholt are very active and keeping an eye out there to help you through any of the things that you get stuck on. There's that speaking at another community call link. And we also have a blog post where we do our latest updates. We have a YouTube channel where we have these recordings of these community calls, as well as some video content. We have another video content project on the dock right now, but I can't spoil too many things yet. So just keep an eye out for that in the coming months. And then we also have Twitter/X/whatever you like to call it, and make sure to follow us on that. And I did miss something from the agenda. I will also be talking through the hallway track that I gave at HashiConf for those of you who are not able to be in person for that. So that will be part of the agenda after Mark Tinderholt goes. But with all that, assuming there are no questions, that pause is for questions. All right. I will turn it over to Mark Tinderholt. Mark is also more affectionately known in the community as Azure Terraformer. If you've ever seen this goofy guy make a hilarious video, then I'm sure you'll know who he is. We personally got to meet him at HashiConf, and he's great. Really funny guy and really cares about Terraform. And a full disclaimer, he does not work on the Terraform team. He is not here to give prescriptive guidance on behalf of the team on the truths of Terraform on Azure. He is just a really passionate dude who does this because he loves Terraform. So really appreciate him. Gonna hand it over to him and let him take it away. Thank you, Mark.
Thanks, Stephen. Yeah, so that disclaimer, don't listen to whatever I say. It's not official Microsoft stuff. I just hack a lot, but appreciate the intro. And let me share my screen over here. So I promise I'm not going to have a lot of slideware, but one of the things that I'm trying to get better on my YouTube channel is maybe give a little bit more diagram context of what I'm about to go code. So I thought I'd start with a little bit of that today. So a little bit about me. I work at Microsoft. I have to announce that on social medias and publicly whenever I talk. As Stephen said, I do not work in any way related to Terraform at Microsoft. I'm just a user of Terraform. So you can call me an amateur Terraformer. But you know, in a former life, I've used Terraform, you know, in a variety of ways on AWS, on Azure, on GCP. You know, experimented with things like, you know, the Kubernetes provider and things like that. Stitched together in a lot of different ways with a lot of different tools and different pipelining tools, and just fell in love with it. I just love it. I think it's a great tool, and you know, that kind of fuels that passion. It's a lot of fun, you know, working with Terraform. And so when I get an opportunity at my day job to work with Terraform, it's awesome. It's a wonderful thing. But we do a lot of like bicep and ARM internally and things like that. So those are not always a given. But anyways, this is me. I'm an amateur YouTuber. You know, I felt like there's a lot of AWS content out there around Terraform. Like you throw a rock and, you know, in the Terraform world, and you're probably going to hit an AWS guy who doesn't know anything about Azure. And so I thought there was a gap in the community, like about, you know, real practitioners using it. I'm not saying I got all the answers. I've just been working on Azure for a long time and working with Terraform a long time. And so I thought I'd put them together. You know, niche of a niche on YouTube. You know, that's my retirement strategy. We'll see how it works out. But it's been a lot of fun and engaging with the folks that, you know, watch my stuff and watch my ramblings. And I learn a lot of stuff actually from questions and comments that people leave. So it's been a heck of a time. I'm having a great time. So today, I was going to talk about a topic that I haven't hit yet on my channel, which is Ansible, right? And you guys may have seen my recent parody video, which it still cracks me up when I watch that thing. And the total eclipse of the heart is ingrained in my brain for like, you know, like a week now. But you know, it's a gentle jab at some of the other tools out there, and I think that video is not trying to say other tools are bad, right? It's just like there's passion and there's love for when one tool does its job really well. That doesn't mean Terraform is the tool to end all tools that does everything. Terraform just does its job freaking awesome. Yeah, somebody's out there. Hey, Steven, can we mute the little baby? Hi, baby.
Hi, baby.
I don't speak baby.
All right.
I suppose we all speak
that
baby.
Should have solved it.
Thank you, sir. Yeah, so yeah, the thing about Terraform is that it plays well with others, right? I mean, it does its job really well, and there's a lot of tools out there that do their job really well, right? And so I don't take that video as, a thing that I think that, Terraform is the only tool there is. It's just a really cool one. And as you know, I've worked with a tool called Packer a lot on my channel. And I have not worked with this tool called Ansible on my channel a lot, but that's going to change. And because I think Ansible is a great tool. And so I thought today I would just kind of show, a basic way that I've used Ansible with Terraform and Packer actually together to kind of leverage the strengths of each of these tools kind of in combination with each other. And so I have a code base out in GitHub. You can pull down all this code. I got it working literally this morning at 8 a.m. You can check my commit history. So kind of procrastinating on this one, but it works. At least it worked at 8 a.m. I put some delete locks on my resource group so nobody deleted anything. So hopefully we won't have trouble with the demo. But basically this is how this works, right? Over here, we have, can I use a little pointer? I guess you can see my mouse. We got Packer, and Packer, we describe what's going to go on the virtual machine. And we use Packer to basically bake an image, a virtual machine image. And the code base that you can go access on GitHub, basically I'm provisioning an Azure Compute Gallery, and I'm provisioning an image definition. And Packer, once those things are there, Packer will go, if it's pointed in the right direction, it will go take this HCL template that has, how I want this virtual machine to be configured. It'll execute those commands, and it will bake an image, and it will save it as an image version within that image definition. So that's step one. And so Packer's a great tool for anything that, is really slow moving, that's big, that takes a lot of time, that you're not going to change a lot, right? So if you're installing, big software, configuring, files and things like that, you can bake that into your Packer image to save time when your virtual machine scale set is going to scale out, your workload to handle those spikes in traffic. If you don't bake that into Packer, well, you can still scale out, but you're gonna have to do all that heavy lifting in post provisioning, right? And so having it built into the image, it's kind of like it's compiled in there, and you really just have to wait for the VM to become healthy and light up, right? And then usually there's the last bit of thing that you need, which is what I call kind of last mile configuration. It's where there's certain things that you don't know until you spin up the VM. Like these are runtime specific configuration. This could be like DNS, or it could be an IP address of the load balancer, different things like that you need to, or different environment variables, right, that you need to pipe in so that your application, code that's probably baked into your image, when it wakes up, lifts its head, and it's like, oh, okay, who do I talk to? Like, where's my SQL database? Where am I getting traffic from? Who do I need to talk to do service discovery, things like that. That stuff you won't know at the time of baking the image. And so this is where post provisioning can come in really handy. And there's a lot of different ways you can do that. And virtual machine extensions, you can add some cloud init, for some user data to your Terraform code. But again, it comes back to which tool does the job really well. And Ansible is a fantastic tool for pushing updates fast to existing virtual machines, right? So if you want to do patching of an existing environment, if you want to do real-time config changes, right? Maybe there's some drift that's been injected into your system and you don't want to shut down VMs. Ansible is a great way for pushing those config updates to those virtual machines so that you don't have to, you can minimize downtime and minimize outages. So again, different strategies for getting basically the same job done, which is how is my operating system configured? How is my application configured? And they each have their strengths. And so here in this code base, I'm using them in conjunction with each other. And I have a Packer template. I build a very mundane image. You're gonna laugh. All I do is like run app update and app upgrade. That's it. And then I have some Terraform code that provisions a virtual machine scale set, a few VMs, a VPN gateway so that I can connect to it and run Ansible, because I haven't like automated the Ansible in a pipeline yet. And it doesn't really demo well, but you'll probably see more about that on my channel. And then I drop an SSH key, a shared SSH key into a key vault, and I use that for my VMs. And I'm ultimately going to use that to connect with Ansible. So that's kind of how it works. Any questions about the architecture? But I'm going to double click on the interface between Terraform and Ansible. But this kind of gives you a broad picture of what Packer's doing, what Terraform's doing, and what Ansible's doing. Tim.
Yeah, we have a similar thing coming up. We hadn't even considered using Packer to build the VM image. And I'm curious, what is Packer using as the file format to put that in the compute gallery?
So Packer, the file format, it actually produces a managed image out on Azure. So the Packer, just like Terraform, it has a plugin framework, strategy pattern, right? Where you can target different platforms. There's, as you might imagine, an AWS. Actually, there's a few of them. An AWS plugin. There's a GCP plugin. There's an Azure plugin. And they can be configured in a lot of different ways. But what it ultimately outputs is a virtual machine image, and then in a resource group. And then you can configure the Azure plugin for Packer to target an Azure compute gallery so that you can take advantage of the coolness of a compute gallery to kind of add some structure, around, versioned history of images and things like that. So does that answer your question? Did I hit all of them?
Yeah.
Okay.
Thank you.
Yeah. And actually, I've even at Microsoft, I've used this strategy, and we've found ways, where we can share code between basically the scripts, bash scripts that do the install. We share code between Packer and Ansible, such that when Packer bakes it into the image, like when we run Ansible, Ansible is going to go and do the same check to make sure the things are there, and that way we only have to update the operating system configuration one place. Next time the image gets built, we're going to spit out a new baked version of that, of whatever Ansible is going to make. So, right. But it allows us to spin up new environments with the new hotness. But with Ansible, we can, immediately touch our existing environments and update that configuration with the new hotness immediately while minimizing downtime. So I think I'm also going to spend a little bit of time on my channel talking about, how you can share code between a Packer template and a set of Ansible playbooks. So any other questions?
I think you might have just answered it in the last bit there, but I come from a world where we use Packer and Ansible a lot, especially with physical infrastructure. But with Azure, we're kind of I've almost been pontificating about like cattle versus pets and immutable infrastructure. So do you still see a play for Ansible in that immutable infrastructure world, or is it just kind of what you said there? I think you answered it though, like that quick hits use Ansible, but then fill your playbook back to your Packer template. And is that kind of what you're thinking for the long term?
Yeah. And I mean, Packer helps us get closer to the kind of the holy grail of immutable infrastructure with virtual machines, but virtual machines are not as are not as nice as like Docker and Kubernetes, and like as just being able to quickly push an image and have that thing like insta fire up, right? So I think when you're managing production systems using virtual machines, it's really hard to achieve full, you know, immutable infrastructure like practices, just because of practical realities of like the engineering that it would take. I'm not saying it's impossible, but the engineering that it would take, you know, to achieve that. I mean, you'd basically be having to do a lot of crazy stuff like with blue-green cutovers and, you know, a lot of stuff in the load balancer, intelligence on the load balancer to spin up new VMs and then kind of siphon traffic away from the VMs that are going to go away. Because with virtual machines, you literally have to pop them in the head, right? And then spin up a new one from a new VM. So there's, I guess, some physics involved that just makes it cumbersome with VMs.
Got it. Yeah, that's good. That's a good point. Like I said, I don't know if I said this, but we're not doing a lot of IaaS right now with Azure. A lot of it's PaaS, but in SaaS. But there is a conversation. We have a lot of stuff in rack space, and we're kind of thinking about moving it to Azure. So there's talking more about IaaS in Azure. So it's becoming a topic.
Yeah, and I would say I think the strengths of Packer and the strengths of Ansible can be applied, you know, within the realm of where they make sense. And Packer is about, you know, speed of launching VMs, whereas Ansible is about speed of applying updates to existing things, right? So if you want to, and this Packer, like baking it into the image becomes really important when you want to dynamically scale, right? Because you don't want to wait for Ansible to like, as like if you scale out a bunch of new VMs that are using marketplace images or just baseline OS images, and then you use Ansible to like update them, and then they say, okay, like Ansible's done with me, I'm ready to actually do stuff now. I mean, there might be a crap load of stuff that Ansible has to do in order to get that thing traffic ready, right? Not just OS healthy ready, but like, hey, I can actually be productive and handle traffic now. And that's like baking that in the image. It's literally like you just spin up a VM. Once you get closer and closer to, you know, traffic ready gets closer and closer ready to OS health ready, right? And it's like, it's almost insta. So there's trade-offs that you got to evaluate there. Cool. Thanks. Good questions. Any other questions before I move on? Okay. So this is kind of what the handoff looks like between Terraform and Ansible. So Ansible, like Terraform, is a command line utility that processes code in the form of YAML files, as we saw in the previous diagram, and basically goes out and through SSH talks to virtual machines and evaluates like what the configuration of that machine is. And so what a couple of really important things that Ansible needs: one, it needs an SSH key, right, that it can use to communicate with those virtual machines. Two, it needs to know what virtual machines to talk to, this is called an inventory. And then three, there's probably some variables, right, that need to be piped into Ansible to set the context so that, you know, certain runtime attributes like who's the database, like what managed ID, you know, should be used, et cetera. Those can be piped in and inform the playbooks that Ansible is going to run against those virtual machines. So a technique that I've used, and I know there's an Ansible provider out there, that thing dropped pretty recently, and it dropped right in the middle as I was building my own like solution like this, where we were, you know, using Packer, Terraform, and Ansible together. And, you know, so I didn't have a chance to evaluate it. I'd be curious if once you see my approach here, if you have experience with the Ansible provider, I'd be curious, you know, what your thoughts are with that. But basically, my approach here is Terraform is responsible for provisioning the virtual machines, right? And basically, it has all the information, you know, that I need to populate the inventory and the variable inputs to Ansible, because Terraform knows what managed ID those virtual machines are attached to those virtual machines. It knows the private IP address of the VMs, the host name, any custom DNS we're using. It knows everything. And so I can, in my Terraform, using a local variable or a local object, I can construct a data structure as a local variable, and I can use a Terraform function called YAML encode, and I can spit out a YAML file that looks exactly like an Ansible inventory file. And likewise, I can spit out a var file that looks exactly like an Ansible variables file. And so really, it's just a matter of once Terraform spits those things out, either through Terraform out or local file resource, it's about piping those into like where the Ansible command line is going to execute, right? So it's kind of like Terraform. Ansible is kind of like Terraform in that way, in that it operates from a working directory, and there's certain, magic files that it looks at, in order to set its context. And when you run an Ansible playbook, just like Terraform, you can kind of run in a, read-only mode, like, hey, let's go detect what the deltas are, which is this command line, except with -- check, right? So it's not exactly the same vernacular, but it's the same concept, right? It's just Ansible is going to go talk to the VMs, analyze the state of the VM as it compares to what the playbook, has in its plan to execute, and see what has changed and what actually needs to be executed on the VMs. And once you want to go actually make that so, you just remove the check and you run this command, and Ansible will go fire all those things and make it happen. So pretty parallel concepts, but they do very, very different. They're hitting a different control plane. Whereas Terraform hits the AzureRM control plane, Ansible is literally SSHing into the VM and running commands. That's it. Any questions on this before I move on? We're going to look at all this code right now. This is my last slide, so we're going to dive into it. Any questions before we dive in? And I know going a little over on time, Stephen, I hope that's all right. But I think I can, once we get in the code, I think I can wrap it up here pretty quick. All right, no questions. Here we go. So, bada bing. So here's my code base. Let me make it a little bit bigger, okay? And so the structure of the code base, I have a source directory, which has my Packer code, my Terraform code, and my Ansible code. And the Packer template, it's all HCL, just like we talked about. This block right here is basically telling Packer how to talk to Azure. This block right here basically saying, hey, Packer, once you got a VM up and running, this is what I want you to go do on that VM, right? And where you'd have kind of crossover between Ansible and Packer is through bash scripts, right? So you can see here I'm using inline bash, right? This is not the way of sharing code between Ansible and Packer, but the way that you would do it is you'd share bash scripts between your Packer template, which your HCL would then reference those bash scripts, and those would be the same bash scripts that your Ansible code would reference. So just I didn't, for this simple demo, I didn't do that, but I'm just thought I'd point that out there. There we go. And then, so looking at the Terraform, I have my main, and this is pretty standard Azure stuff. I got my resource group. I have my compute, and where using Ansible to manage existing systems, it's not when you got like one VM. It's when you got like a cluster, a whole bunch of them. And usually it makes sense when you've got very stateful workloads, like massive MongoDB or Cassandra workload, or even Vault or something like that. I don't know. So I set up a little module here, and the where I use this, we had an active cluster. Basically, we had a VM scale set in each region that was multi-zonal, and we balanced traffic across those clusters or data centers, right? So in my real world example, I would have like several of these clusters, and they would all hit different regions. For my little demo today, I just have one of them, and it produces 3 virtual machines. But you can see I've got, at the cluster level, I'm specifying some things that are cluster specific, like how many nodes do you have, Mr. Cluster? What region do you want to go to? But then there's also VM specific config, like what SKU should you use? What SSH key should you use? What should be the default admin? What subnet are we going to split these guys into, right? So those things are set up at the cluster level, and then I'm using local modules to keep things simple. Looking at my cluster, I have a VM scale set. This is an orchestrated VM scale set, which uses the orchestration mode. And then I'm using count. Don't hate on me, okay? I'm a simple creature. I still use count sometimes when I'm doing quick and dirty. Yeah, laugh all you want, okay? It's easy. It's quick and easy. I don't have to convert things to a map. But anyway, so here I am just creating 3 nodes in my cluster and configuring some disks and things like that. So that's pretty much it, right? And what this produces, let me see if I can find it over here, is I've got this resource group that's got some nodes in it. I got a VM scale set, I got a virtual network, and I got a VPN gateway. And for the sake of this, I have set up the VPN gateway, so I'm already connected to it. Okay, so I think I'm good there. Now remember, I said earlier, Ansible communicates over SSH. So you got to have network line of sight to this stuff. So if you're going to run this in GitHub Actions or Azure DevOps pipelines, your build agent is going to have to be connected to your network. Okay, so this is why I'm using point-to-site VPN. I'm literally just jamming my little MacBook here onto the same network as my VMs here so that I can run Ansible. So that's what I'm going to do right now. So over here, here's my script, and you can see, like a good little boy, I've been doing some testing before this demo, but I can run this command right here, and I'm going to run check. Hopefully all goes well. I swear to God, there's not many times where we're going to watch paint dry, but running Ansible here, we'll see how the network responds. But now you can see I'm getting okay, and I see a bunch of private IP addresses, and that's basically in the Ansible inventory. Ansible is going out, pinging each of the virtual machines, connecting to it, and then running the YAML playbooks against it to see like what it needs to go do. Right. And in my Ansible playbook, it's just like trying to update the latest, some version of Python. So it's not anything fancy, but you can kind of get the idea of how this stuff works. So while we can see that thing's running, and it says, okay, nothing changed. And this is very similar to like a Terraform plan, right? It's like, what needs to be changed? In Terraform, it's like created, destroyed, changed in line. Right. So the same concepts kind of apply, and you can see I got OK 6. That means 6 things are as expected. So I don't have to do nothing. Right. And no changes. So this is good. This means there is no drift. So how does this work? Right. Let's go back to my code here. Looking at the Ansible directory. Okay. The way this works is I have this YAML file right here. And I'm generating this YAML file as an output in Terraform. I literally am creating this structure because this is the structure that Ansible has been set up to use. Ansible has this concept of all nodes, and then you can set I made up this. This is a creative writing exercise. I just called them cluster. I could call this Marky Mark and the Funky Bunch, right? And as long as there's a corresponding group of that, in the config, it's gonna run the playbook on it. So right here. So I've got roles common, and I've got my group of hosts called cluster. This is where Marky Mark and the Funky Bunch would go. And then, yeah, I'm not very creative. I don't claim to be. But you can see here, I'm using roles common, and that hits this directory. And inside here, I've got more YAML files that basically go do the things, right? And in this, I'm dropping an Etsy profile and doing some fun stuff like that, right? So this is all, this is not new to like Ansible people, but, dropping the inventory file is kind of where the rubber hits the road from a Terraform standpoint. And so all I do is in my Terraform code, I simply build, and this is gonna look a little scary, but these two objects right here are my local variables that I just YAML encode and output to a file, and that is the exact same file that I'm using in my Ansible directory to go talk to these machines. So also interesting, I wouldn't do this in production, but I also happen to be generating a TLS key. So the SSH key that I'm using, I drop this in Key Vault. I provision the VMs with it. I also dump this to a local file so that, when I run Ansible, I've configured Ansible to use the same SSH key. So you can go pull this. Yeah, this is on a public repo. You can go pull this code, and I've tried to design it so that it'll work. Like you can just clone this repo, and it'll just work out of the box. You just have to, provision some things. You have to provision the Azure Compute Gallery, which is in this folder right here, the gallery folder. You have to provision the application, which is my cluster. You got to run Packer to put the virtual machine image out there. And then once all that's done, Terraform apply will put the inventory, the vars, and the SSH key in this Ansible directory so that you can go run Ansible. But you got to connect to the VPN. So there, I'm trying to make it sound simple, but there's a few things going on here. But if you got site to site, and or like Express Connect or something like that, like it would be a lot less work to get that done because you already got network line of sight. So any questions after looking at the code? How does, what's the role of Terraform? How do we get, the things out of Terraform into Ansible? Any questions on this? Is this making sense? I've stunned them with silence. Okay. So yeah, that's pretty much it. That was my demo. Ansible's great, Terraform's great, Packer's great. They all do different things. You just got to use them for what they're really great at, and that's the bottom line of of picking the right tool to do the right job. So thanks everybody. Stop sharing and pass it back over. Yeah. Check out my channel. I'll probably do, I got to plug Steven. Check out my channel. I don't have any Ansible stuff on there yet. There's a lot of Packer, a lot of Terraform, obviously. But love the support, really appreciate it. And yeah, ping me on Slack, say hello. That's it. Thanks a lot, guys.
Thanks so much, Mark. I really feel like I got a lot out of that too, just learning about how Ansible works together with Terraform, and they kind of can elevate each other in that sort of manner. So appreciate your time as always, and yeah, looking forward to some of the future content you put out. So
thanks, man. I told you I was long-winded, so whoever
you did,
got sick,
but
whoever got
you know
sick,
what?
it's like no worries.
Nothing wrong with that. Nothing wrong with that whatsoever. So awesome. Well, what I have for you guys today is a basically redo for those of you who might have been at HashiConf with this hallway track. But this is just a version for all of you who weren't able to come in person. And since we're in the community, I will try to talk less fast because I don't have a strict 15-minute time limit where they're going to kick me off the stage. That wasn't actually the case, but I'll take my time more so here, and I can stop and take questions as we go through this, as people desire. So one of the things that we really wanted to talk about this year as a team was around service lifecycles and services themselves. As many of you know, there are seemingly countless services in Azure, and that list only continues to grow. Those features that are coming out in these services are oftentimes really important to improving the workflows for you and your team. And that is one of the things that you have always looked for since years past to exist within Terraform. So our team has obviously invested for years on Terraform, and the goal there was to co-own and maintain the AzureRM provider alongside the dedicated folks in the HashiCorp side. And essentially, we want both teams to support these features for you, no matter what it might be. As long as it's coming through Azure, we want, and it's important to you guys, we want to make sure that every single Azure service as a result is ready to go by the time that GA hits. And obviously, that brings a question in of what the heck is GA and what is the service lifecycle in our eyes. And this is a very, very short version of what we would kind of consider. On a high level, Azure services will generally start in private preview, and then they will move over to public preview. They have a set of requirements that get them through from one step to the next. But the protocol really tries to ensure that services are launched at a sort of high enough level so that they, well, hopefully work, right? When a service is generally available, really what that means for us is that it's a stable service and being committed to having maintenance and development from a service team for at least a few years to come. And then they'll launch from there with new versions and features and updates, so on and so forth. But the Terraform team's commitment has always been to support every Azure service when it becomes generally available or GA. So that has always been the case for us. I want to quickly pause. Anything confusing about that whole service lifecycle that I just described? And I'm about to get to the providers themselves. So if you have questions there, I'll hold off for 10 seconds. Okay. Seeing as there's nothing, I will keep going. So let me try to walk through how the Terraform team interacts with these services and how they end up in Azure RM. Basically, the first step that kind of occurs is that some team in Microsoft decides we're going to launch a new service or feature. Then they'll go ahead and go through that internal process I just talked about there. And they're going to contact our team early on in that process to ensure that support for Terraform is ready. We begin the process of implementing support for that resource in Azure RM. So that process will be done through our engineers for a little bit. And then once we're ready, we make a PR. Once we think that the resource is ready to be merged, that resource gets merged into the Azure RM main branch, and that will be included in the weekly releases. Excuse me. One of the things that I will note here is that there is a manual implementation step here. And one of the biggest pain points that we have recognized from you as a customer is the lag in resource support for Azure Terraform. Obviously, the team doesn't want anything to lag, and we try to invest heavily to ensure everything is supported by GA. But, you know, we're all human here. Things happen. We run into issues and bugs and things that just exist as a result of that manual implementation. But we heard that feedback for a while and we wanted to do something about it. So we decided to create a different provider that would, instead of going through a manual iteration process, promise the ability to auto-generate a service as long as it went through Azure. So it was capable of housing support for services in private or public previews, as well as solving the problem that we most heard from you as a customer. And that provider that we announced almost a year and a half ago now, I think, was the AzAPI provider. So these two providers, in our eyes, would help kind of bridge that gap. And we thought that it would be important for everybody to kind of go ahead and experience the benefits of AzAPI to help address that. But one of the questions that came up in that process was, well, when do we use the AzAPI provider and when do we use the AzureRM provider? And the initial story that we told was that AzAPI is meant to be used for people to essentially go ahead and provision their infrastructure when it's not available in AzureRM. AzAPI would be a preview, or when something's not working in the AzureRM provider, you just tie it to AzAPI. And then once that gap gets filled, you move things over to AzureRM. What we wanted to specifically talk about today, or I guess even back at HashiConf, was the question that people would ask, which is, well, if it's just a gap filler, why do we use it? So we thought about that. We talked internally and even got some feedback from some of you, and we appreciate that feedback. But we realized that this provider solves a major problem that a lot of people are facing in AzureRM. And we wanted to kind of say, you know what? Let's not just call this a gap filler, because I think the wrong impression that we gave was that this was going to eventually be done away with as soon as you were able to, bridge your manual gaps. So the news story that we're kind of telling here is that we're saying, hey, each provider has success, each provider you can succeed with in your Terraform infrastructure journey, but we want to provide clarity moving forward on what you can do. So if you're working on latest and greatest features, and here we're thinking of stuff like AKS or some of the new preview services that have not yet been released, AzAPI is our recommendation as Microsoft. It offers individual resource versioning, and it even offers support for data plane resources and action resources, which are basically making any sort of calls in the API world that are not CRUD friendly. And that should, in a sense, be able to hit everything in the Azure world that you care about. Again, like if something is GA, such as AKS, and you're using it, you don't need to feel the need to move over to AzureRM. You can continue to use AzAPI. And the way that it would work is it would actually go ahead and you can preview, you can change your API versions to integrate some new preview features into your configuration. AzureRM is still going to be around, and we're not planning to do away with that either. We are really still believing that this is going to be useful as a stable experience, as a convenience layer. Resources are in an experience that is as simplified as possible when you utilize AzureRM, and that is really still there for whenever you need it. But we do think that both have full support from Microsoft, both have full investment from Microsoft, and we have a guarantee from our team that we will continue to improve their experience and maintain those resources that live within that life cycle. These both have their own extensions in VS Code, and I do want to call out, as I see in some of the chat as well, that we also fully support you using both. And when I say that you can use it for example, AKS, that you can use it for AKS AzAPI, but you could also use AzureRM for something else within that same configuration. And we fully are in support of that as well as a story. The upcoming projects, if you will, in the world of both of these is AzAPI. We are trying to work to remove JSON encodes from there. We know that the JSON encodes don't look too pretty For those of you who use it, you do know that there is IntelliSense in the VS Code extension. So it's not a terrible authoring experience, but I think we all have some scars from the ARM template days, and we would like to do away with all the JSON that we could. And the other thing that we're working on is modules. The thing with modules there is that we acknowledge that AzAPI is tying to resource versioning, and that can sometimes shoot you in the foot. So we want to make sure that we can have some sort of pseudo convenience, and you can go ahead and use AzAPI with those modules to get the versioning tied together to handle those versioning matrices, but you can still go ahead and get the latest and greatest. And then AzAPI to AzureRM is one of the tools that we have been investing in. We are trying to invest to see if we can make it able to do the reverse. And we are also looking to see if we can implement CI/CD support for it, which would also be an ask that we have heard from you as a community. And there's one shout out in terms of recent features that isn't on this slide, which is that we have released support for the AzAPI provider in Azure Export for Terraform. And just to give you an idea of what that code looks like, I will quickly show you one that I ran just now. And this is full disclosure, the not a release yet. It was just merged, and it will be included in the next major release. But this is what currently AzAPI export looks like. So here I just took a VM configuration and went ahead and said, okay, let me take all of the stuff in this VM and export it. We have here the VM, we have the NIC, we have the extensions, everything in here. I would say definitely if you're curious, and go run a go install on the GitHub repo on the latest main PR for, or the latest commit on the main branch, and see what you think about it. We are in the process of obviously trying to improve this, and there are still steps that we believe we can take to make this experience better. But as a whole, we're excited to bring that to you, and we hope that you guys now have the confidence, now that we have kind of said this, not only at HashiConf, but now here, and also moving forward, we will continue to say that AzAPI is going to be around, that we are going to fully invest in it, that it can be you can treat it just like AzureRM in terms of it's not going to be something you can't just deploy and then fear that it will someday blow up or something like that. We're going to continue to invest, and we're going to continue to care about the provider. So that was everything in regards to a loose summary / rendition of my hallway track, but I'll open it now to any questions that anyone might have.
The question I have, it's not directly relevant to what was discussed, but in general, Terraform and Azure compared to ARM Bicep in investment. So the two things which I personally find hugely missing from day-to-day operation is ability. If you deploy through ARM, you have a deployment tab within the portal and see what the progress is, and also can go back in history and easily figure out what actually happened when ARM/Bicep was used. This is missing. I understand it's probably because Terraform just works so much differently that it cannot be described there. You have to go activity log and take a look at individual API calls, but it's a bit mess if for somebody who tried to move to Terraform, number one thing. Second is obviously missing from a UI and general API to ability to export any kind of resource directly from a portal, which you can do currently with ARM. Not with Bicep, I believe, but I think it's in the work. So that was two things. I'm wondering if this is something team invests in, or it's just because it's so much different, it will never be implemented and all hope is lost.
I will take the second one, and I'll let Mark talk about the first one. We are working on export experience for Terraform in the portal. We hope that we can announce something soon, is all I can say.
Yeah, it is something that, like Steven says, we are working on that. It's something that a lot of customers have asked for, so we understand the importance that it is to all of you. So we are really working hard to add to that. As far as the first question goes with the kind of the logging and tracking of Terraform runs in the Azure portal, what you're essentially seeing there is the Azure deployments tracking. And since, as I think you mentioned, Terraform doesn't use deployments, so it doesn't use templates. That stuff doesn't show up in the portal. Terraform is a different beast, and essentially you should use whatever you're using to run Terraform. So if you're running it in a CI/CD pipeline, you can track the runs and history there. If you're using Terraform Cloud, you can use the history there. But essentially, whatever you're using to execute Terraform is what you should use to kind of track that history and log that history. Currently, we don't have any plans or actually any way of integrating with the deployments logging right now. So.
And just to shout out what was in the chat, there is also the CLI tool that I just was demoing, which is Azure Export for Terraform. You can go to the GitHub link that I posted in the chat there, but that is a way of using it, not through the portal, unfortunately, but like I said, we're hoping to announce something soon. So I see a hand raised. Sorry, I can't see all the names right now, so.
Philip?
Yes, it was me. Thanks. I know it's maybe a little bit specific because you're depending on the product groups and the APIs, but I think the Azure Container App support in the AzureRM is really lacking much features. I don't know why is that so. For example, you still cannot configure the platform cider, the reserved one. So especially when you use private integration with on-premise customers, let's say, you want to define this platform cider, but you can do with the AzAPI or Bicep. And also, I think since 2 months or 3 months, the keyword references are GA, and there's still no support in the AzureRM. There's a ticket open since, I don't know, May. I don't know why is this so, the lacking features for the container apps?
I don't have an exact answer for you on why it's
Yeah, no, it's specific, I know.
lacking from a container apps perspective. I know it's something that we are working on with the HashiCorp team. And there are some kind of some complications from the API and how it interacts with Terraform or how Terraform should interact with it. So it takes a lot of times with some of these APIs, it really takes some tweaking to get them to work the way that Terraform should work. So it just takes some time. And that just kind of goes back to what Stephen was talking about, where because there is manual implementation from the AzureRM perspective, it takes time, and we are continuing to invest heavily in it. But it takes time sometimes to get some of these things implemented. So.
Yep.
I want
Okay,
to
thanks.
I want to go in order of when I saw questions. I know there's a hand raised, but in the chat, we've been pushed by Microsoft to use PIM. PIM support in Azure is lacking a lot. Even trying to go to AzAPI, all the templates are beta or preview, and they've gone through 3 major versions in the last year and a half. In the case of onboarding PIM for groups, Microsoft doesn't seem to even open the API for AzAPI to call. Mark, you want to take this?
I don't have any details on that. It is something that's come up on my radar. It came up in the last week or so. So we are going to have the team dig into it and see what we can do to add support for that and to see what's missing there. So we are looking into it. I just don't have any details on where we are. It's been pretty recent that it's come up on my radar.
Tim, feel free to Slack us your details, and we can take and kind of that as feedback and also bring it to the devs as a scenario, just so that we have a bit more clarity on what sort of things are missing there or what you're looking for.
Yeah, for sure. And I appreciate your answer, Mark. That I know it's specific, but man, it's been the biggest pain point. Like if you've got, say 100 subscriptions, you got to set up PIM groups for all of those, and you're your identity management team's like, cool, so I got to spend 3 weeks like clicking through the portal just to, like, you want to Terraform it and just, you know, do a for each loop and get it all figured out, but it's just not there yet. So yeah,
Sure.
I'll line up with you on Slack, and maybe I can put you in touch with the guy on Microsoft that we've been working on. That's been, I
Awesome.
think he's close to the product team for PIM. So yeah.
Cool. Appreciate it.
The next one, and then I'm gonna get to the raised hands, is do you have a tool or a GitHub to generate diagrams from Azure Terraform? We don't have an official one, but there are some that were put in the chat here that aren't necessarily Microsoft backed, but sure they all work great. Brainboard or Structura, you can use those, but we don't have an official Microsoft one that we're gonna try to bring into the equation there. And Dominic, I think, was first up, so I will let you go.
So I was going to ask about using subscription IDs in the Terraform provider block. Right now, it only accepts subscription ID, and I'd like to use the subscription name. Is that something that is like feasible, or I know that it could potentially not be unique, but we could just have it like error, because I try to avoid having like the subscription ID just hard coded if I'm going to be like publishing my code on GitHub. So I'm wondering if there's reasoning behind that, or why it's ID only right now.
I think you touched on it there. It's the uniqueness of it. And if you have a name that can be duplicate, there's really, I mean, we can error, but that's a pretty bad experience from a Terraform perspective in that when you try to connect, it's just going to fail. So we certainly can look into it a little bit, but the primary reason for having that is it's the unique ID for that thing, for the subscription.
And then the other thing I wanted to ask was the Terraform stuff connects using the AZ CLI, and it was kind of mentioned earlier that PIM has support that is probably better in the CLI than it is in Terraform potentially. So is there a way that's better than using like a null resource with provisioning stuff to use AZ CLI to provide or to provision things? Because it has the show and the update capabilities, but using the null resource stuff is kind of not my favorite experience. So I'm wondering if there's a better way to do that as well.
I'm not sure I specifically follow that, but the only place that the CLI is actually used for authentication is when you're using the when you're logging in manually. If you're using service accounts and stuff like that, it's not used for that, or the SPNs. It's not actually used for those authentications.
I think the question, correct me if I'm wrong, Dominic, is if something's working in the CLI, like PIM stuff, is there a better way to utilize Terraform for calling those CLI commands? Is that correct, Dominic?
Yeah, because the Terraform lifecycle is it does a GET request to see what the current state is, and then through that it identifies the changes that need to be made. And with the AZ CLI, we can get resources and find their current state, and then it also has the capability to do the updates. So I'm wondering what if there's a middle ground between the full provider support versus having to jump down to shell commands to invoke the CLI to make changes using Terraform and track life cycles.
So that is exactly where the AzAPI comes in. You can literally do anything using AzAPI instead of using the command line itself. So if you use AzAPI, you can call those APIs directly using Terraform syntax and saving stuff to state. So you get the full fidelity of Terraform, but you have the granularity of not only calling puts, but you can call posts and any other REST call itself using that. So you really should have absolutely no reason to fall back to using the null resource with the CLI between the AzureRM provider and the AzAPI provider.
Perfect. Thank you.
All right, Mark.
This came up in an internal HashiCorp Microsoft call. There was some reports of certain Azure services having certain requirements for Microsoft Graph permissions. And I think it's an area of friction that we should probably look at addressing. The instance that they brought up was related to SQL managed instance and how it needed tenant reader access within a Entra. I'm still getting used to the new name, Entra ID tenant. So I would imagine there's other services that have similar. This popped in my head because somebody mentioned the PIM thing, right? There's other areas where the AzureRM provider has a little bit of overlap with Entra, but the problem is the different people, manage the Entra permissions than the people that are grokking the AzureRM provider, right? So I don't know if there's an easy way to solve this one today, but I think it's something we should probably chase down with the PMs to see like what the right level of privileges user assigned managed identity should have within Entra tenant when they get created. Just want to throw that out there. I thought it was an interesting problem space.
Yeah, for sure.
All right. We have any more questions? Tim, go ahead.
Sorry, one last really quick one. There in the Azure RM provider, we've got a resource group lock, or kind of a resource lock. You can set it for cannot delete or cannot modify. Pretty basic. The problem is every time we use that resource, Terraform, the graph builder for resources has no concept that I have to drop that lock if it's a cannot delete before I do any modifications on a resource. And so we've had a couple of novel engineers, add a pipeline step that can be manually triggered and say, okay, drop all the resource group locks, then do the work you're going to do. Okay, then go back in. Yeah, it's just not a great experience. I wonder if you guys are aware of this. I've seen this work off and on in the past. It's just something I want to put on your radar.
Interesting. So I think I get the scenario, but it's interesting that you would want to automate the removal of the locks. That seems to be kind of counter design for the locks almost.
It does, right? It's we don't want people in the portal to monkey with the resources, but if it's going through an IAC pipeline, great, that's fine because it's PR'd, it's approved, it's good to go. That's the context, really.
Okay.
So
Yeah, that is something I was just going to say real quickly, and then Mark, you can jump in, but that is something that we have kind of in mind to some degree, because one of the benefits that customers see with the stacks, the deployment stacks that are coming out, is just that you can essentially lock down ARM template and bicep deployments using deployment stacks to only allow changes coming from that deployment stack. So it is from a usability perspective. We'd like to provide some similar functionality. We just don't have plans to do that yet, or an idea for how to do that, but that might be something that would enable that scenario that you're looking for.
I was sorry, I didn't mean to jump in there, talk over you, Mark, but it's almost like we need like an exclusion list, or like to whitelist certain identities that can bypass the locks, right? Like, and these would be like machine IDs, like maybe a managed identity or a service principal. I guess any Entra identity could be added to that, but that would allow certain personas, like the managed ID for your GitHub
Service
Actions pipeline.
That would be way better. That's not a bad idea at all. We had that. I think Microsoft Blueprints had something similar, working on the background to maintain that lock.
Yeah, and that's what Blueprints has turned into deployment stacks, and that's kind of the feature that I was talking about there.
That'd be cool.
Yeah.
Got to talk to the PMs. I don't
That's
know
what
what
you're
PM
doing.
owns that.
Any last questions? I know we're a little over now. All right, sweet. Thank you all for your time. Really appreciate it. We managed to fully flesh out the more than an hour at this point. So big thank you to Mark for coming in and being the great guy that he is, and really just appreciate all of you. We had great attendance today, and looking forward to the next one. It'll probably be next year. So if we don't see you till next year, happy holidays, everybody. Have a great Thanksgiving, Christmas, New Year's, everything in between. So thank you all.
Thanks, everyone.